When you were in grade 7, we discussed that an object accelerates when any of the following changes is observed. There is a change in speed, meaning the object is speeding up or slowing down. There is a change in direction. The object moves to the right or moves to the left or moves in a circular path. We can say that the object is accelerating. Or there is a change in both speed and direction. One good example of this scenario is when you ride a roller coaster. There is a change in speed and direction. Now, let's proceed to our topic for today, a recall on forces. We were able to discuss that force is a push or a pull. Whenever we exert a force, we either push or pull an object. So these are examples of forces. So let us discuss them one by one. But before we discuss the different types of forces, let us first discuss what a force vector is. So force can be represented by a vector, and a force vector is represented by an arrow. So we can draw an arrow to represent force. And how do we draw an arrow to represent a force? What does the arrow represent? What does the arrow represent in terms of the force vector? So the body or the length of the arrow represents the magnitude of force. How much force is exerted to an object can be expressed in terms of the length of the arrow. So it is measured, it is expressed rather in Newton, which is our unit for force. So suppose you have 5 Newton force. So if you will represent a 5 Newton force, you can use a scale of 1 centimeter is to 1 Newton. So if you have 1 centimeter is to 1 Newton as your scale, if you will draw the arrow, the length of the arrow will be 5 centimeter to represent 5 Newton. Now, if the force is directed to the right, we use the arrowhead to represent the direction of the force. So the direction of the force may be up, down, left, right, north, east, south, west, northwest, northeast, and so on. Okay? Now, let's proceed to the different types of forces. First, gravitational, gravity, or weight. They mean the same thing. So this refers to the pull of the earth. It is represented by an arrow directed downward because the pull of the earth is directed downward. The symbol for gravitational force, gravity or weight, is F sub g. So gravitational force is the reason why an apple fell on Newton's head. So the force is exerted, or the pull is exerted on the apple, causing it to fall. So the direction of the force is downward. The symbol for the force of gravity is F sub g, or F subscript g. Next, normal force or support force. So normal force or support force is an upward force exerted by a surface at an angle of 90 degrees. So this is an example of a normal force. So a normal force is a force directed upward because it is the force exerted by the surface on the object, and it is always at a 90-degree angle. So this is for normal force, wherein the surface is horizontal. You will see that it is 90 degrees. While when the surface is inclined, you will still see that the surface exerts a normal force at an angle of 90 degrees. The symbol for normal force is F sub n, or F subscript n. Okay? Next, tension force. So tension force is the pull exerted by a string or a rope on a hanging object. So whenever an object is hanging, there is a tension force exerted by a rope or a string. One good example is when you have a hanging ball pen. The tension force is directed upward. The symbol for tension is capital letter T. Okay? So, it is the pull exerted by the string or the rope. The symbol is capital letter T. So, whenever you pull something using a string or a rope, you are exerting a tension force. Frictional force. Frictional force is the push that opposes motion. So the symbol for frictional force is F sub F, or F subscript F. So it is represented by an arrow directed to the opposite direction of the motion of the object. So in this case, since the frictional force is directed to the left, the object is moving to the right. So if the object is moving to the left, the frictional force is exerted to the right. So it is opposite the direction of motion. Always opposite the direction of motion. Elastic or spring force. It is the push or pull exerted by elastic materials like a spring. Okay? So the symbol for elastic or spring force is F sub S, or F subscript S. So the direction, or the symbol for this force can be downward, upward. It depends on how the spring or the elastic material exerts force. Now, since a force is a vector quantity, it can be represented by a force vector. We can also make a free body or a force diagram of forces acting on an object. It is important that you know how to make a free body diagram or a force diagram, because in your succeeding activities, you will be asked to draw a force diagram. So, I have here an example of a force diagram of the forces acting on a physics book. There are two forces acting on the physics book that is at rest. First, the table pushes upward on the book, and this force is called the normal force, while gravity pulls the book downward, which is the gravitational force. So these two forces are acting on the physics book. Take note that when you draw a force diagram, the two forces should start from the center, the geometric center of the object, because it is perceived that the geometric center is where the mass of the object is concentrated. So it is where the force is also exerted. Okay? So, I repeat, all force vectors should start from the object's center of mass. Forces acting on one point in an object are called concurrent forces. So the normal force and the gravitational force are examples of concurrent forces because they act at one point, which is the center of the object. Okay? Another example is a soccer ball on the surface. So, if you are going to represent the force diagram, you need to identify first the forces acting on the soccer ball. So, the gravitational force, which is directed downward, and the normal force, which is directed upward. Okay? So, remember, these two forces are acting on one point, so they are considered concurrent forces. Another example, okay? Normal force, gravitational force. So, if you will observe, all these forces are acting on the object's center of mass, and these forces are concurrent. What if the object is moving forward? Okay, so there is a forward force on the book. Suppose you push the book. So, since you exert a forward force on the book, you push the book, there is another force that will act on the object, and that is the frictional force, the force that opposes the forward force on the book. Take note, they are acting on the same point together with the normal force and the gravitational force. So these forces are concurrent.